Hey guys, okay, I'm gonna be recording those videos and uploading this on YouTube. It seems that videos can be more than 12 to 13 minutes. Supposedly, I made an hour worth of lectures. I tried to upload them and they wouldn't upload, and I had to do them again. It's not a problem. And I'm gonna upload the PDF of what I'm doing, basically what I'm writing in this tablet in our files, just the usual place. So the goal here is really to get to start to do the problem, not pretty much to get to the answer. How do you approach the problem? 7.5 is really mixed enough, 7.1, 7.2, 7.3, 7.4, and we just have to figure out which is which and how to do the problem. The most challenging part is figuring out where to start. And you'll notice 1 through 82, the entire section is evaluate the following intervals. So pretty much straightforward as far as directions. Now we need to figure out what does it match, so kind of like which section does it come from, and how to start the problem, which is the most challenging part. So I'm going to start with something like problem number 2. So again, I'm picking and choosing, I'm diversing the problems as much as I can. I have a list I'm going to go through. If you don't get this, that's certain problems, but I'm marked by them. When we have our class discussion, we could talk about this. This is on page 547 in our book. So this problem, if this was a square, the power, then I could FOIL. In this case, I can't FOIL. But I could switch the order. I could say let u equal 3x plus 1 and du will be 3dx, meaning I am going to take this and put a u instead, and that's raised to the radical 2, and dx would be du over 3. I should change the limits on the integral. That is, I should say if x equals 0, u would be a 1, and if x equal 1, u would be a 4, and this way I don't have to go back and substitute x back in. This is a very useful technique, especially when you do trig substitution, and this is nothing more than a power function. You add 1 to the power, divide by that, and proceed. Again, if you can't finish any of these problems, I suggest you ask in class, and I strongly suggest you pause the video every now and then, attempt to do a problem on your own, and see if you could do it. For example, you look at problem number 4, you should first think about it before you look at what I'm going to do, and if you're stuck, then go ahead and figure out what I'm doing, and we go from there. So I'm glancing at this, and I'm looking to see sine and cosine, and one of those is odd, so I know the drill. I'm going to take this top sine cube and write that as the sine of x dx. That's my du, if you remember. Which means, what's left? A cosine of x, but this sine squared I'm going to write as 1 minus the cosine squared of x, and if I let u equal cosine of x, du will be negative sine of x dx. So this becomes the integral, and if I take that top portion, that's 1 minus u squared all over u, and my sine of x dx is simply negative du, and I could split those up, integrate, and go from there. Don't forget to resubstitute u back into the equation when you're done. If I look at problem number 6, so again, the new use of a u-sub, it really allows us to switch the order of the fraction, meaning instead of having a over b plus c, which is a bit more challenging, we could kind of manipulate this to b plus e over k, which I could split and work easily. So if I let u equal 2x plus 1, then I could say du is 2dx, and I'll notice This will become the integral. Now, just so that I wouldn't lose track, that is my u cubed. Dx is 1/2 du, and I have this x left, and the deal was I would solve this for x, so an extra step in there will be u minus 1 all over 2 equal x. So I would multiply by another 1/2, and that will be a u minus 1, and I should also change the limits in the integral. In this case, if I let x equals 0, u will be 1, and if I let x equal 1, u will be 3, and this is much simpler to split. That's 1/4 the integral from 1 to 3 of u over u to the third minus 1 over u cubed. Simplify, add 1 to the power, divide by that, and there it is. So we could finish this. And if I look at problem number 8, if I glance at that, well, I noticed that this is actually the sine of t2 divided by 2 from section 7.2. So, parts. If I let u equal t, du will be dt, and if I have dv equal the sine of 2t over 2, I don't know why I'm squishing that. Let me just move that to the right and restart this code. If I have dv equaling the sine of 2t divided by 2, then I will integrate, and v would be negative the cosine of 2t divided by 4. This will be u times v minus the integral of d du. And of course, that's negative t the cosine of 2t divided by 4 plus the sine of 2t. When you divide by another 2, that becomes an 8. Now, if you know what to do with the board, it's easy. The problem happens when actually we do not know where to even start the problem. And that's why this is a very important section for you to really tackle. See how many of those you could get. And if I take problem number 10, it seems the first round of problems are very good problems because they are diverse. So if I glance at that, my first attempt on every problem, by now hopefully we're really comfortable, is if I let u equal the angle, the argument, the denominator of a fraction, the exponent, right? The argument of a log. So if I let u equal 1 over x, du will be negative 1 over x squared dx. Here I have to be a bit patient and work at this slowly. That's the cosine, and this is my u. But when I take x cubed, I notice there's an x squared, so I could take care of the negative easily, but I should think of this as x squared times x, and 1 over x squared dx is actually negative du, and I noticed there's an extra 1 over u, which was my initial u sub, and this becomes integration by parts one more time. So in this case, and I know it's kind of odd, but you could let u equal u, or w equal u if you wish. Du is, and you could let dv equal the cosine of u du, and you could integrate, and that would be negative u the sine of d minus the integral of d du. And you could finish this up. Do remember to substitute u back in, otherwise it's a problem. So whatever the original problem is with respect to, I need to integrate with respect to the same unknown. And if I go for number 12, and I glance at that, and what do you think of that? Well, this is 2x minus 3 over x into x squared plus 3 dx. Now I would try a U-7 every problem. To take a derivative of this, that wouldn't work. So I would go on the side and say, well, let's do 2x minus 3 over x into x squared plus 3. That is a over x plus dx plus c over x squared plus 3. So in this case, if I clear the fractions, I could figure out exactly what a equal. And just by finding a, pretty much I simplified the problem. Now probably it's best to continue and say, you know what, let's stick with the Brooks method. We're not going to use this trick that I showed you, because I could, if I want, pick two values of x, but since I already found a, this should be very easy to figure out. So here we know that a plus b must equal a 2, and 3a plus c must equal a negative 3, but I do know what a is. If I put a negative 1 there, that means b is 3, and if I put a negative 1 there, that means c is 0. So c is 0, and that is a 3, so this is actually the interval of negative 1 over x plus 3x over x squared plus 3 dx. That would be negative natural log of absolute value of x, and this will be 3 times 1/2 natural log of x squared plus 3. I don't even absolute value in the second log because that's always positive, but if you write that, I'll let it slide. So I have to stop here. This is 12.5 minutes. I'll continue on in the next video.